Hello everyone. In this video, I will discuss about the question 2 in the second homework. If you see my older video, you will find it's very similar with the question 3 in first homework. Let's see the problem first. So there are several noise channels, and it may change the signal or not. And we are wondering, given probability, we will get what result at xn. So it's known that the probability of x1 equals 0 equals 0.2, and the probability of x1 equals 1 equals 0.8. And we have the probabilities that the probability of xk plus 1 equals 0 given xk equals 0 equals 0.6, and probability of xk plus 1 equals 1 given xk equals 0 equals 0.4, and the probability of xk plus 1 equals 0 given xk equals 1 equals 0.3, and the probability of xk plus 1 equals 1 given xk equals 1 equals 0.7. The first sub question is to find the probability of x2 equals 1, and we need to consider two cases. The first case is x1 equals 0, and the second one is x1 equals 1. So we just multiply the probability and calculate the sum of these two cases, and we will get the answer equals 0.64. And the second question is to find the probability of x3 equals 1. So just like the first sub question, we consider the case that probability of that x2 equals 0 and x2 equals 1. So we already get the probability of x2 equals 1, and we can calculate the probability of x2 equals 0 by 1 minus probability of x2 equals 1, and multiply them and get the sum of these two cases. The answer is 0.592. The third sub-question is to find the probability of x1 equals 0 given x3 equals 1. So we know that the probability of this equals probability of x1 equals 0 and x3 equals 1 divides the probability of x3 equals 1, and the probability of x1 equals 0 and x3 equals 1 equals the probability of x3 equals 1 given x1 equals 0 times probability of x1 equals 0, and we can divide it into the case use x2 to divide the probability of this of the first one, and it becomes the probability of x3 equals 1 given x2 equals 0 times probability of x2 equals 0 given x1 equals 0 plus probability of x3 equals 1 given x2 equals 1 times probability of x2 equals 1 given x1 equals 0, and times probability of x1 equals 0. So these properties are all given in the problem, and we can get the answer equals 0.296, and then we can get the answer. Use 0.296 to divide 0.592. It equals 1 divided 2 equals 0.5. So we have half probability. And the last question is to find the probability of xn equals 0 when n is infinite. So we will first use matrix form to represent connections between probability of xn equals 0 and the equals 1, and the probability of x1 equals 0 and x1 equals 1. And when n is infinity, if there has such a probability, it must satisfy this equation that after one matrix multiplication, it still equals itself. So we assume that P equals the probability of x n equals 0, and we have such two equations that 0.6p plus 0.3 1 minus p equals p, and 0.4p plus 0.7 1 minus p equals 1 minus p, and we'll get p equals 0.429.